Welcome. Previous class we have discussed that if a compound is given, then we used to calculate that number of signals. Let's say you have the compound CH3, CH2, Cl. If this molecule is given, then we used to calculate that number of signals. So for that, what we say that 3H we have that 1 signals, and this 2H will have that 1 signals. So here the total we have the 2 signals. Okay, and you know that in NMR data, if it is, then we have that standard reference. After that we have that chemical shift value. So 2 signals are there, so two signals will be like this. Okay, now the thing is we have to calculate that. We also know that this is electron withdrawing groups, and if electron withdrawing group is attached, that will give that high chemical shift values, high chemical shifts. And if it is electron donating groups, then it will give the low chemical shift values. Okay, so now we see that this is electron withdrawing groups. So this CH2, let's say this is A protons and this is B protons, then this is attached with electron withdrawing groups, so this should have high chemical shift value. So this is, let's say this is in ppm chemical shift value, so this way this is increasing, so here that chemical shift value is increases. So this CH2, this A should have that high chemical shift value, means A should be lie somehow here. Okay, and this B, HB will be somehow here. So this is that how the position of signals, where it is located, that we have discussed in the previous class. Now in this class we will discuss that what is that exact chemical position, chemical shift or position of the signals. What is the exact position of the signal? Okay, that we will discuss today. Let's say now we have that this CH3, this CH2, and here any groups. Okay, for this case we have that G equal to Cl groups. So G can be any groups, and if G is, let's say I'm going here, this G is here, for this case Cl group, so this G can be any groups. Then what is that chemical shift values will be, that we will discuss. Okay, before that we will look, let's say if you have that any molecules and we have that chemical shift value, that is this, and this is in ppm. Okay, so if any molecules, let's say we have the 3-degree carboguidance, let's say this is that, and CH3, this is CH3, or any groups, and now we are talking about of this. So these hydrogens will have that chemical shift value, that is 1.7 ppm. Okay, now if it is, this is the 3-degree carboguidance, and if it is 2-degree, let's say this, and this is any groups, and we have that H, here we have that H, this is any groups, then this is 2-degree carboguidance, then this will have that chemical shift, that is 1.3 ppm. Okay, now if it is, let's say 1 degree, so C, here is H, here is H, here is H, so this H, now this H value is 1.3 ppm. So for this H, this is 1 degree, so this H will have the 0.9 ppm values. Okay, so this we have to remember these values, that if it is 3 degree, on that this hydrogen is there, then that value is 1.7 ppm. If it is 2 degree, that H value will be 1.3 ppm. If it is 1 degree, that H value will become 0.9 ppm. With that, if it is, let's say that triple bonds are there, sp, and if you have here that hydrogen, on that case its value will be 2 ppm. And similarly, if you have that aldehyde groups and this H, and this H value will be that is 9 to 11 ppm. That is 6 to 7, 8, 9 to 11 ppm. And if it is acid groups, on that this H will have that 11 to 12 ppms. Okay, and if it is this groups, this is double bond, and here that hydrogen, this vinyl hydrogen will have, and for that this has that 4.5 to 6.5 ppm. Okay, so this value we have to remember that what is its ppm, what is its values. If it is 3 degree, it is, so this value is very important. 3 degree 1.7, 2 degree 1.3, and 1 degree 0.9 ppms. And if it is double bond, then 4.5 to 6.5 ppm, in between some range will be there. And if it is 3 degree, then this is 2 ppm. Okay, and if it is aldehyde, 9 to 11, if it is acid, 11 to 12 ppm. So in this range its hydrogen's chemical shift value will be lies. Okay, so now what we have discussed, that another things, if it is OCH3, okay, OCH3, then this H has that chemical shift that is 3.5 to 4 ppm. Okay, OCH3, and OCH2 value will be high than OCH3, that will be 4 to 4.5 ppm. Note that OCH3 value is lower than this is OCH2. OCH3 value is lower than OCH2. This has the 3.5 to 4 ppm, and this is 4 to 4.5 ppm. Okay, and this is very important, because with this concept only we can solve lot of questions. This and this, so this we have to memorize it. Okay, and this value is also important, we have to remember, but these are very important, this and this. Now we will discuss that. Let's say we have that CH3, in this case CH2, we have that Cl. So any groups like CH3, CH2, and here we have any groups, let's say here G equal to Cl, so any groups, so according to this G, that increment to this will happen. This is 2 degree carbocation, so this have that value is 1.3 ppm. Okay, so now due to G, some value will be increases to this 2 degree carbocations. Now how that value will increase, let's say I am writing here, this is carbon groups, and we have that nitrogen groups. I'm ordering according to electronegativity, first carbon, nitrogen, then we will have that oxygen group, then another oxygen groups, then we have that fluorine group, not halogen group, I am writing fluorine group. Okay, this is carbon groups, this is nitrogen groups, this is oxygen groups, 2 time oxygen groups, and this is fluorine groups, and this order is according to that electronegativity, based on electronegativity. Now this increment, for this increment we will have that is 1 ppm, and for this increment we have that is 1.5 ppm, just increase by 0.5. okay, this will be 2 ppm, and this will have 2.5 ppms, and this will have 3 ppm. So I am just increased by 0.5. Okay, so for this carbon groups, so what are the carbon groups here? Like all the carbon groups. Note that whenever I am writing in this type of groups, or just write it, so carbon group means all the carbon groups will be lies here. So let's say this carbon, it may be double bonds, or it may be the triple bonds, so whatever that groups, okay, that will all increase by 1 ppm, or it may be any this type of groups, or it may be any this type of groups, any electron donating groups, or it may be any electron withdrawing groups. So any groups it will like, then they will have the increment of 1 ppm. Okay, with that also we have the groups like that is SR2 or SH2. This all will do the 1 ppm increment, but not that whenever this type of groups will comes, this type of groups, except this carbon, other case this will be changed. I'm writing for nitrogen groups. So all nitrogen groups, that is N R2, or it may be NH2. Okay, and it may be NR2 or NH2, and here that benzyl groups will come. In these groups, not that benzyl group will come. Okay, so whenever these penyl groups will there, not benzyl, the penyl groups will be there, that is also do the 1.5 increment. And here that SR2 SH2 is there. So if it is these groups, if it is CO will be there, any that OH, this type of groups will come, then this will come to the 1.5 ppm. Okay, normal this will be 1 ppm, and if this type of groups is added, this type of groups will comes along with sulfur, then this will come to the this groups. Okay, this is 1.5 ppm. So whenever if that normal is there, after that this group added, that will be comes to the 1.5 will be increment will be happen, means that will come to the next group. Okay, so these are for these groups, and for these groups, oxygen groups, here whatever all oxygen group, that is OH or it may be OR, this type of groups, and groups that whenever this N will be there, after that this CO type will be added, then this will come to these groups, or it may be any groups like this type of groups will come, then this will falls in oxygen groups. And here also we have the groups, that is SO2R group will also fall in these groups. Okay, and in these groups also we have that is except chlorine, all halogen will be fall in these groups, like chlorine and bromine and iodine, all will fall in these groups except fluorine. Okay, all halogen will fall in this group. Now in this oxygen groups, in this only one group is there, that is this type of groups. This will have the 2.5 point increment, and for this fluorine group, that is 3 ppm increment. In these groups we have that all that highly electron withdrawing groups, that is NO2 groups, that is fluorine groups, and this oxygen groups, we have the oxygen, and now it is this type of is attached, then this will fall in these groups. Okay, so this is that how the groups will fall. So you notice that whenever this type of groups will be there, then that will be not fall in the same, like here we say that nitrogen is there. With nitrogen, if this type of will happen, this will fall to the next groups. Now this falls here, see this falls, but this is nitrogen, but whenever this attached, means it will fall to the next group. Similarly here we have that oxygen, and in oxygen if it is attached OCR, then it will fall to the next group. It will not come to these groups, because this is for this group only, this is only present. Okay, for 2.5 mm only this group. Okay, so it will pulse whenever this will attach with oxygen, then it will come to the next groups. Okay, and here that chlorine and nitrogen will pulse, and here all that halogens except chlorine will fall in these groups. So this is that how the increment will be, that is first we will do 1, then 0.5, 1.5, then 2, then 2.5, then 3 ppm. Okay, so now that questions is that you have that CH3, CH2, Cl in the questions. Now here that Cl is the Gl, so G that will have these groups, that is 2 ppm increment. It means that this CH, this is 1.3 ppm, this is 2 degree, and for G it have the value of 2 ppm. It's the value of 2 ppm because this halogens fall here, so this value will be going to be 1.3 plus because of this 2 ppm, so total will going to become 3.3 ppm. So these hydrogen atoms will have that point that is lies in 3.2 ppm. Okay, so now we will say that this HA atoms, this will lie 3.2 ppm. Okay, and this is what, this is that this is 1 degree, so 0.9 ppm, so this will lie nearly 0.9 ppm. Okay, so in this way we can say that what is that value, what is that exact value of a particular protons. Okay, so whenever we discuss the coupling constant, then we will discuss details, we will discuss previous year questions, because previous year questions asked with chemical shift with that coupling constant, mixed questions are asked. So after completion of a coupling constant, we will discuss previous year questions. On that we will clear more about of this increment values. Okay, this one you have to remember, OCH3 has 3.52 per ppm, and this has 4 to 4.5 ppm. Okay, and these values we have to remember. This you have to remember, memorize. Okay, and for this they have some trick to memorize these things, these values. That alternate way they is to do that, that is first is 0 to 2, 2 to 5, 5 to 8.5, then that is 10, then we have the 12. Okay, and this is 2 to 3, so this is in ppm. So this value is lies all that carbon atoms without electronegativity substituent, without electronegativity substituents. Okay, and here that with electronegativity substituent, this is sp3 carbocarbons. Okay, sp3 carbocarbons without electronegativity substituent, it with electronegativity substituent, and this is sp carbocarbons, that type of protons. And here this lies 5 to 5, just a minute. 2 to 5, this is sp3. Okay, this is sp2, for this case sp2, and this is aldehyde groups, and this is acid groups. Okay, this way also we can memorize by this 0 to 2, and this is sp, and this is sp3, and this is sp2, and this case of aldehyde, this case of acid groups. Okay, so today after this, thank you.